Artificial intelligence doesn't think, it doesn't understand language, and it has no idea what it's saying. Yet today, we can use AI to write emails, generate images, answer questions, and help make decisions across entire industries. And increasingly, people use it to discuss things they might not share with anyone else: personal worries, private thoughts, and everyday dilemmas. So how can something that isn't intelligent appear so capable? To understand this, we need to look at what AI really is, and what it isn't. Join us as we explore how AI actually works beneath the surface. Most people imagine AI as a kind of digital brain, something that understands meaning, reasons through problems, and forms ideas like a human mind. This assumption feels natural because AI communicates using language, the same medium humans use to express thought. But language fluency is not the same as understanding, and this is where the confusion begins. When humans use language, words are connected to experience. We attach meaning, emotion, memory, and intention to what we say. We understand context. We know when something is true or false. We recognize nuance and implication. Human intelligence is grounded in awareness and experience. AI has none of these. Modern AI systems do not understand words. They analyze patterns. At their core, large AI models are prediction engines trained on enormous amounts of text, drawn from many different sources, including books, articles, websites, public documents, and other written material available in digital form. By learning from this vast collection of human language, AI systems absorb statistical patterns about how words, ideas, and concepts tend to appear together. This does not give AI knowledge in the human sense. It does not read and comprehend information the way people do. Instead, it builds a mathematical map of language, relationships between words, phrases, and contexts, based on how often they occur and how they connect across millions of examples. Because these relationships are stored in numerical form inside the model, AI can generate responses almost instantly once prompted. Because the training data spans many fields: psychology, health, science, daily life, and countless other topics, the model learns how ideas from different domains are often connected in human language. For example, discussions of social anxiety frequently appear alongside themes like avoidance, confidence, therapy, or stress. Conversations about eating habits often overlap with topics such as emotion, reward, metabolism, or nutrition. By observing these recurring relationships across millions of examples, AI can generate responses that link concepts from different areas in ways that appear informed or interdisciplinary. But this does not mean it understands psychology or nutrition as subjects. It reflects patterns in how humans talk about these subjects and how those patterns intersect. When AI generates a sentence, it is not recalling facts or forming ideas. It is navigating this learned pattern space and selecting the most statistically likely next word. Then the next, and the next. This process can produce language that feels meaningful, even insightful. But the mechanism behind it is probability, not comprehension. Behind every AI system are teams of researchers, engineers, and organizations that design and train these models. AI does not gather knowledge on its own. It is built through a process in which humans collect large data sets, design learning architectures, and run extensive training on powerful computing infrastructure. During training, the model is exposed to enormous volumes of text and adjusted repeatedly so that its predictions better match patterns found in human language. This process can involve months of computation across thousands of specialized processors. Engineers guide what data is included, how the model learns from it, and how its behavior is refined. In this sense, AI reflects not only patterns in language, but also choices made by the people and institutions that build it. What the system learns depends on what it is trained on, how that data is filtered, and what objectives its designers set. So while AI can appear autonomous, it is fundamentally shaped by human decisions at every stage of its creation. Understanding AI, therefore, also means understanding the human systems behind it, the researchers, companies, and infrastructures that make large-scale learning possible. To understand what this looks like in practice, consider how large language models are trained. Organizations developing AI systems assemble vast collections of text from many sources: books, websites, articles, and other publicly available writing, and use this material to teach the model statistical relationships in language. Training occurs on specialized computing clusters containing thousands of processors designed for machine learning. During this process, the model generates predictions about text and compares them to real examples, adjusting internal parameters billions of times to reduce error. Over repeated cycles, the system becomes increasingly effective at predicting how language is structured and used. But this process is not entirely automatic. Teams decide what data is included, what content is removed, how outputs are evaluated, and how the model should behave in different situations. After initial training, additional stages often involve human reviewers who rate or refine responses so the system better matches desired qualities such as usefulness, clarity, or safety. The result is a system shaped both by large-scale data patterns and by ongoing human guidance. So when AI produces fluent language, it reflects not only statistical learning from text, but also extensive engineering, curation, and evaluation carried out by people. AI can sound intelligent because language itself contains structure. If you predict language well enough, you can mimic reasoning without actually performing it. This is similar to how autocomplete on a phone predicts sentences, except AI operates at vastly larger scale and complexity. It has seen more text than any human could read in many lifetimes, so it can assemble patterns that resemble explanation, argument, or analysis. But resemblance is not understanding. Humans are naturally inclined to attribute intention to anything that communicates fluently. When something speaks coherently, we assume there is a mind behind it. This instinct evolved for interacting with other humans. AI exploits that instinct unintentionally. The better AI becomes at producing natural language, the stronger the illusion of intelligence becomes. We begin to treat outputs as thoughts rather than predictions. This misunderstanding has real consequences. If we assume AI understands, we trust it more than we should. We rely on its outputs without verification. We attribute judgment where none exists. But AI does not know when it is correct. It does not know when it is wrong. It does not know anything at all. It only predicts what text is likely to come next. AI demonstrates performance without intelligence. It can complete tasks that normally require intelligence: writing, summarizing, translating. But performing an intelligent-looking task is not the same as possessing intelligence. A calculator performs arithmetic flawlessly, but it does not understand numbers. AI operates in a similar way, but across language and knowledge patterns. As AI systems improve, their outputs will feel increasingly human. They will appear more knowledgeable, more confident, and more persuasive. The risk is not that AI will think like humans. The risk is that humans will believe it already does. Recognizing the difference between prediction and understanding is essential for using AI responsibly. Artificial intelligence is one of the most powerful technologies ever created. But its power does not come from thinking. It does not understand the world. It models how humans describe the world and comes from pattern recognition at an unprecedented scale. And recognizing that distinction may be one of the most important forms of literacy in the coming decade.